Hi, everybody. I'm Bryan Norcross. Welcome to the podcast. Luke Doris is on weather duty today. He's covering Potential Tropical Cyclone Nine that is forecast to become a tropical storm as we're recording this here this afternoon, but he'll be back with us soon. This is podcast number 5 of hurricane season 2020 and number 43 in our series of podcasts. Today, we're going to talk to Dr. Phil Klotzbach on the podcast. Phil is famous, of course, for the Colorado State University seasonal hurricane forecasts that he helps produce now. But we have a lot of things to talk to Phil about. We always do. We'll bring in Phil here in just a minute. As I said, as we're recording this, we're watching this very large disturbance that's just east of the Caribbean islands now, and it's this elongated oval-shaped disturbance that has 2 areas of intense thunderstorms. Now, the National Hurricane Center, but especially the computer models, have been focusing on something kind of close to the top of that oval as a center to where this thing would congeal and consolidate and organize and then move on toward the Caribbean islands from that center. Well, hurricane hunters are out there as I'm speaking to you now, and it doesn't look like that's where the center is. If there is a center, it's much farther to the southwest, coming up on Barbados, and that's going to change the forecast. So there's a lot of uncertainty about this system based on its structure, let alone the problems with the dust that's all around it and how that's going to affect it. And also the fact that it's moving so quickly. When storms move this fast, this one is kind of officially going at 23 miles per hour right now. When it goes really fast like that, then if you think about it, the circulation has to go at least more than 23 miles an hour on the bottom side of it to have a west wind, because the motion will cancel out the west wind on the bottom side. So it's a little hard to get a west wind. So it's hard to get a circulation out of these kind of storms when they go that fast. So that's another negative factor. So we'll see how all this comes together when the hurricane hunters finish their work and they feed it into the models. It's going to take until tomorrow, I think, until we get any kind of accurate forecasts for this system. If it does develop, it's going to be called Isaias. That's the Spanish and Portuguese name for Isaiah in English, Isaias. The way it works, this naming works, the World Meteorological Organization has a committee, and the committee is made up of people from English-speaking countries like the United States, from Spanish-speaking countries, from French-speaking countries, and from Dutch-speaking countries. So this name, no doubt, was put into the hopper by one of the Spanish-speaking countries. Isaias will be the name of this storm if and when it develops, and of course it is supposed to. So in the tropics, just looking at the season in general so far, the real tropical season really just began last week because we had Gonzalo and Hannah as the first tropical systems. Before that, all the systems were non-tropical originally. They were kind of wintertime lows that went out over warm water, extra warm water this year surrounding Florida and then the Gulf and on the East Coast. And so that got enough energy from the ocean in there to create a system that was tropical enough that got a name. So that those first 6 don't really count in terms of the tropical season. But now we are seeing storms develop through tropical processes, these last 2, and this one as well, if it develops Isaias. So that's a sign that the tropical season is underway, and it's underway even pretty robustly for getting those 6 storms. Normally, tropical season really ramps up, of course, toward the middle of August through the 3rd week or so of September. We'll talk to Phil Klotzbach about that coming up. That's from a statistical standpoint. That's when the big hurricanes are likely to form. We're recording this podcast on Tuesday, July 28th, 2020. If you're listening at some point in the future, tune in to Channel 10 in South Florida, of course, for Local 10 News, where we'll have the latest on the tropics. Or you can watch Local 10 News on local10.com at any time. All the newscasts are there live anywhere you are. You can see them On the weekday afternoons, they begin at 3 o'clock in the afternoon, continuously to 6:30, otherwise at noon, 9 in the morning, and of course early morning news and late evening. Also, the Max Tracker app has the latest tropical information, and the Local 10 Weather Authority app also has the latest information. So all those sources, you can get the latest weather information through WPLG Local 10 in South Florida. On this date, more or less, so yesterday actually, so July 27th, there was a hurricane in South Florida that was significant almost. That scared everybody in July 27th of 1926. It came by, moving kind of from south to north up the coast, ended up staying enough offshore that it just did very limited coastal damage as it went by Miami-Dade and Broward County, today's Miami-Dade and Broward counties. It ended up coming ashore kind of in north central Florida, and it was a big storm at one point. It was a Category 4 storm as it moved into the Bahamas, did a lot of damage in Nassau. That was July 27th, 1926 as it came by here. And then 2 months later, the Great Miami Hurricane came along in September of 26, and of course that was this devastating storm throughout Dade and Broward County, and it ended up being, as a matter of fact, one of the most important hurricanes ever to hit the United States. The people that analyze these things say that if that storm happened again, it would be the most expensive storm to have ever hit the United States, $200 to $250 billion worth of damage. If it happened again, it was a giant storm, came right at Miami. But then a month later, another super hurricane came. It devastated Havana, just missed South Florida in October. So 1926 was a crazy year, and that 3 hurricane scenario began on July 27th. Just the anniversary of that was just yesterday. So let's bring in Dr. Phil Klotzbach. Anytime I want to know how often anything happens with hurricanes or anything to do with stats, I get a hold of Phil. He is the king, the guru of hurricane stats. You know him, of course, for the famous seasonal hurricane forecast produced by Colorado State University that Dr. Bill Gray started in 1984, and then Phil took him over when he was a graduate student, and now he works with Dr. Michael Bell, and they turn out those forecasts several times a year. These days, more than 25 organizations and agencies make those seasonal forecasts, but of course the very first one was done there at Colorado State. So let's say hello to Dr. Phil Klotzbach. Hi, Phil. Welcome to the podcast. Great to see you.
Thanks so much for having me, Brian.
You know, it's a great time to talk about hurricanes, obviously, because it's been crazy. And today, as we're talking, we have this potential tropical cyclone out there, which, as we were talking about, is a name that I hate because I just don't think that people in the general public know what a cyclone is. What's your impression of the term potential tropical cyclone, and how do you find that people understand that?
Well, I think there's always going to be, there's confusion about tropical cyclone versus subtropical cyclone versus potential tropical cyclone. There are definitions for it, and I understand the reason why they have these potential tropical cyclones is because they're anticipating it to become a tropical cyclone, and that they want to issue watches and warnings before the system is officially named, whereas before they couldn't do that. So I understand that's why they have the leeway. But there's going to be uncertainty, especially with subtropical cyclones. How is that different from a tropical cyclone, and how's a tropical cyclone different from a hurricane, and hurricane different from a typhoon? So there's a lot of education that you and I and others just have to keep doing about what these various categories mean. I think especially with this specific one is challenging because it already has tropical storm force winds associated with it. It's just that the low-level circulation is still ill-defined, and once that circulation becomes better defined, then it will go from being a potential tropical cyclone to an actual tropical cyclone.
Yeah, I'm a total believer in the system of having a way to put up the warnings and to put up the cone and to get people interested in it and focused on it before it has the technical definition of a tropical depression or a tropical storm. The name, though, I think disrupts the communications to some degree. And this one is especially interesting because it's such this big, broad oval, and it almost looks like sometimes I think there's more than one center there kind of trying to form, one in the top and one in the bottom. And if that happens, that fight can actually delay things significantly. So exactly where it forms makes such a difference in the track that it adds a significant layer of uncertainty. And this one looks like to me.
Correct. Yeah. And I mean, that makes a huge difference as to where the storm ends up with its final track, as well as its intensity, how much it ends up tracking over land versus over water, how much of the dry air that's lurking nearby. It's been battling that, how much of that gets wrapped into the center. There's obviously uncertainty with every tropical cyclone, but there's a lot of uncertainty with this particular one as to what we're going to be looking at with this storm in a couple of days. Maybe even by the time this podcast airs in a couple hours.
Yeah.
We're talking about right now.
It might be something different. You're right. All right, let's talk about the hurricane season. This is getting into your specialty. It's been record-setting in terms of the number of storms that have been named, but until last week, till we had Gonzalo and then Hannah, they were all kind of non-tropical. They started non-tropical, right? And then they developed enough tropical characteristics. So now we're really into the real tropical system. I don't envy you for trying to figure out how many named storms are going to be in a year, since we can have this thing here where we have 6 that start out non-tropical that really don't fit in any kind of naming or forecasting scheme, I wouldn't think, or easily fit in any kind of forecasting scheme. So you made the point that when there were 6 of them, where we were at a record at that point, that in terms of the amount of energy that they had produced, actually we weren't much different than normal. Now the energy's increased a little bit with Gonzalo and Hannah, I guess. But how does what I wanted to get to is the number of named storms versus the amount of energy they produce. There really are 2 separate quantities, and I know you kind of like to talk about the amount of energy that they produce as being more meaningful.
Yeah, and so the reason that we do, so there's the number of storms you get in a season, the number of hurricanes, the number of major hurricanes, and a lot of focus goes on the number of storms that happen, but you can have a very, very weak, short-lived storm, like most of the storms this year have been. Obviously, Hannah was our first hurricane, so we had 7 storms before we had our first hurricane. So
and even that didn't last very long. I mean,
exactly.
even that was a short one.
So
right.
We use this integrated metric called accumulated cyclone energy, which is an index that NOAA developed about 20 years ago, which basically takes into account the intensity and duration of storms. So most of the storms this year have generated very little ACE in and of themselves. Whereas if you go back to, say, last year with Hurricane Dorian, a very long-lived Category 5 hurricane generated a large amount of ACE. Hurricane Irma in 2017, even more, just because it's incredibly long-lived, very powerful. So we like to use those kind of more integrated metrics to kind of get a better idea of how much storm activity has actually been generated. So 2020, we are well ahead of schedule. I believe as of last I checked, we were the 6th highest in the satellite era, so since 1966 to date. But 2005... So this year, I believe our current numbers, we've generated 14 of these ACE units, whereas 2005, at this date, we'd already generated over 60. We already had 3 hurricanes, including Dennis, which was a long-lived hurricane that was a Category 4, and then Hurricane Emily, which was the only Category 5 Atlantic hurricane on record during July. So it's been an active start to the season. We've had a lot of storms, but in terms of this ACE metric, we're still well behind a year like 2005, which a lot of people are talking about as maybe an analog or similar things. So we're ahead of 2005 in the number of storms, but we're nowhere near 2005 in terms of long-lived major hurricanes.
Yeah, we had Category 5 hurricanes in July in 2005. So then you had time and incredible strength adding up. So in that ACE number, accumulated cyclone energy, you had a lot going on. So if you were to figure out how to kind of rank hurricane seasons in terms of their busyness or their intensity or whatever, obviously kind of like ACE as a measure. Is there anything that's more complicated, more sophisticated that you think might even be better than ACE? Because, for example, Hurricane Sandy, which never got very strong but was incredibly destructive, kind of didn't get counted according to its impact in terms of ACE units, right? It's an example of the kind of storm that ACE doesn't take care of very well or doesn't account for.
Yeah, and so it's hard when you go back very far, just because all we know is basically the winds and maybe the pressure, and even that's back to like 79. The winds, we can go back to the early 20th century and even back to the 19th century with more uncertainty. So there's been a lot of more complicated metrics proposed, like integrated kinetic energy, which is basically like the whole wind field. So Sandy's a great example. It was not particularly strong. I mean, it was max winds near the center when it made landfall were maybe 75-ish miles an hour.
Right.
So borderline
Barely.
Category 1 hurricane, yes. Even though it was officially post-tropical.
Right. Yeah.
But when it came to it was an enormously large storm. And so we recently wrote a paper and published in the Bulletin of the American Meteorological Society where we advocate using pressure as opposed to wind to categorize hurricanes. And the reason that we do that is because max wind gives you the strongest winds anywhere in the storm, whereas pressure is more of an integrated metric that talks about not only the maximum winds, but also overall the size of the storm. So you could come up with a metric like that and use, say, pressure as opposed to wind. They generally correlate pretty well because you'll get some storms in a season that are larger than normal, some storms in a season that are smaller. So when you integrate it over a season, I think you could use either one, whereas if you can have certainly individual storms like a Hurricane Charlie, which was powerful but also very small, whereas you can have a Sandy, which is much, much larger. Not the winds near the center aren't as strong, but it's a much larger area. And when it comes to things like storm surge, size is very important in terms of how much storm surge you get. So there's certainly a lot of different metrics that have been proposed. A challenge, of course, is a lot of those. You can't go back very far just because we don't know, say, what the wind field of a hurricane, like Hurricane Donna in 1960, what it actually looked like.
We have, a little idea, but not to anywhere near what we have today. So you can't compare apples and apples for sure. And I remember when Hurricane Sandy was happening and the pressure kept going down and down. It was going through the 960s, then the 950s, then the 940s. It got into the 940s, right? And the low 940s, actually. And I referred to that as a measure of the total amount of energy in the storm, right? It's kind of a measure of that, because if you have a super low pressure and a super big storm, you don't have strong winds. Super low pressure and a smaller storm, you have stronger winds on average. So it's interesting. And referring to your paper that you wrote about talking about the pressure and how well in an individual storm, how well that correlates with the damage. Are you thinking that, kind of in real time, that people ought to pay more attention to the pressure? Or are you thinking that this is more kind of for insurance companies to understand the potential impact of it? Well, how would you use the pressure?
I think it's important for both, because basically my argument is that there are some special cases, but in general, when the pressure is falling, you either have a storm that's the winds are going up, or the storm's getting larger, or a combination of both. All of which mean the storm is more destructive. And so we even saw that with Hurricane Dorian. Once it kind of got past the Bahamas, the winds were coming down, but the storm was growing in size, so the pressure was staying constant or even dropping, getting a little bit lower. And so I think there certainly is something to be said for using pressure as opposed to wind. It's much easier to measure. It's more accurate than wind. There's a lot of estimates that go into measuring the wind. And certainly over land, when a hurricane makes landfall, trying to measure the 10-meter, exposure wind that's what the Hurricane Center is forecasting, it becomes basically almost impossible.
It is impossible, yes.
But basically pressure, you don't even need, barometers need to be outside. I mean, you can get very accurate barometric pressure readings. And when it comes to the damage that these storms end up causing, that we found using historical data back to 1900, that pressure works better than wind at forecasting the damage that the storms cause. It has a higher correlation also with the number of fatalities that the storms cause. And so overall, we think using pressure works better than wind.
Sort of the total impact of the storm, right? As opposed to the one specific place. Because sometimes the hurricane hunters go out there and they find a lower pressure and they make note in the advisory, but the winds have not responded yet. It can be a harbinger of changes because the storm is growing instead of peaking in wind. Anyway, it's an interesting and challenging communications issue on exactly how to convey that, right? People feel the wind, they don't feel the pressure changes so much. I think that's part of it.
Correct, yeah. Usually with we argue like when you're categorizing hurricanes, it's like when you categorize winter storms or anything else. It's overall, what are you trying to convey? And it's the threat that the storms cause. And certainly when the pressure is dropping in a storm, all else being equal, occasionally the environmental pressure might be lower or something, and that might be taking into it. But generally, it's just lower pressure means more dangerous impacts from the storm. And if storms are growing, that's usually a very bad thing as well. These larger storms have larger storm surges. And while they don't really correlate particularly well with maybe the maximum amount of rainfall, a larger storm, all else being equal, is also going to have a larger footprint of rain. So a larger storm is only going to bring rain to a larger area as well. So there would be some impacts with regards to precipitation.
Yes, exactly. So going back to this season and the first 6 storms of this season that all started out non-tropical, and we had Arthur through Faye. I mean, obviously that was super unusual to have 6 of those kinds of storms. We quite often have 1 or sometimes 2, but 6 is a lot. Do you have an explanation of why this year, what happened this year that generated 6 of them?
That's really challenging because they're all really marginal. It wasn't like they became hurricanes. And so, typically with the seasonal forecast too, what we look for is, the number, if you look at, say, the number of storms and correlate it with something like vertical wind shear, that change in wind direction with height, which when you have a lot of it destroys storms, you correlate to the number of storms with wind shear. There's going to be a correlation, but it's not necessarily that high. But if you correlate to the number of major hurricanes, the correlation with shear gets a lot higher. And that's because you can get storms in not necessarily the super highly conducive environments to reach tropical storm strength and maybe last for a day and then die. Whereas to get a storm to become a major hurricane like an Irma or Maria, where it's going through these, or Dorian, where it's like through these very warm water environments, tons of moisture, super low shear, that's more what we're looking at with these seasonal forecasts. So that's why we forecast the number of storms, but it's more the number of hurricanes, the number of major hurricanes, and again, that ACE metric, more the integrated measure, which is more what we think is, obviously in general, hurricanes have more impacts than the weaker storms. So you can get a lot of rain from a weaker storm, that's the one that impacts, but in general, hurricanes and major hurricanes are the ones that cause the major damage and cause the large losses of life, all else being equal.
Right. And these more, as you say, these more minor storms can kind of occur for freak events. I said this year that these were occurring because you had this general low pressure over the East Coast, and you had unusually warm water offshore of the East Coast in Florida and in the Gulf. So you had sort of incipient conditions to allow a tropical system to form, where in the past, if you didn't have all that warm water, you might have just had a non-tropical low, right? But things had just enough tropical energy to switch it over for the system to be tropical enough to get a name by the National Hurricane Center.
And there's also been differences in the way that in terms of with having subtropical cyclones and things like that, some of these systems may not have been named, especially prior to satellite era, prior to the mid-60s. Some of these storms may not have been named. They may have just been treated as non-tropical. The first subtropical cyclone in the hurricane database came in 1968, so prior to that, they just weren't even handling those. So it's hard to know how many of these would have been named, say, 50, 60 years ago, but certainly most of these storms have been marginal. Like you said, we did have warmer water temperatures off the coast, so these storms that, say, start non-tropical, once they move over land, or once they move over water and they encounter the warmer water, they can kind of intensify from the top down and become these subtropical and then become tropical cyclones. So we've seen a lot of these in recent years. We've had a lot of these kind of subtropical to tropical and then back to subtropical. I think the most canonical case of that was Leslie a couple of years ago, where it was subtropical, went to tropical, and then went back to subtropical, extratropical, then back to tropical. If it was a baseball, if it was to use a baseball analogy, it almost hit for the cycle in terms of covering all the different categories that the Hurricane Center has.
Yeah, and now we have all these measuring devices and ability to measure systems that we didn't years ago. So we know things that are going on that we didn't know back then. And I just think the mentality is different now. There's this goal to be precise, where back then it was more a goal to warn people of really bad storms. It's just kind of a different way of thinking about it.
Correct, yeah. And Chris Lancy, who's at the Hurricane Center, he showed basically, if you look at storms lasting 2 days or less, there was a large increase in those starting around 2000, and a lot of that was due to these microwave sensors, which allow us to detect these kind of weak, warm cores. So again, that's not to say that these aren't storms, that they shouldn't be named, but when you're trying to look for, say, climate change trends, you see these huge increases in number of named storms. But if you say, let's just look at the number of storms lasting 2 days or longer, there's very little trend, and that's because, again, these weaker storms, we're just naming more of them. There's just different kinds of, like you said, there's more emphasis on being precise with naming as opposed to the way that these storms were named maybe in the 60s, 70s, 80s may have been a little different.
Yes, right. So let's talk about the factors that you look at when you make your seasonal forecast. One, obviously, is the temperature of the water out in the tropical Atlantic. How do you characterize the warmth of the water this year? It's not at 2005 levels, but it's warmer than average, I guess, right?
Yeah, it's warmed up a lot recently. So I keep track of a whole bunch of different metrics. And one of the things I've been looking at is basically like a 30-day running average, because you don't want to just say look at the water temperatures today, because they can be kind of volatile day to day. But if you look at it over a 30-day running average, and we look, especially in July, I look at the tropical Atlantic, so from basically right off the coast of West Africa right up to the Leeward and Windward Islands. So that's a box basically defined by 10 to 20 degrees north, 60 to 20 degrees west. That box right now, the 30-day running average, is the fourth warmest on record, trailing. This is using high-resolution sea surface temperature data, which goes back to 1982. So since 82, there's been 3 years that had 30-day running averages warmer than now, and those were 2005, 2010, and 2017. All of which were very, very active Atlantic hurricane seasons. 2005 and 2017 obviously had huge impacts. And then we had 2010, which was basically the year the U.S. had like one of the greatest streaks of luck ever. We had 12 hurricanes in the Atlantic Basin and no U.S. landfalls. That was just a great streak of luck because on average about 25 to 30% of all hurricanes that form in the Atlantic make U.S. landfall. Obviously, we've already done worse than we did in 2010 because this year we've had one hurricane and it already made U.S. landfall. So we haven't had as good a streak of luck as we had in 2010. And in general, like I said, about 25 to 30% of all the hurricanes that form in the Atlantic Basin hit the U.S.
And if you look at the water temperatures in July, you have some confidence that that trend is going to last in hurricane season, I know in general. But was it 2013 that it flipped in the middle of the year as it started out warm and then suddenly turned cool? Do we understand why sometimes it tends to change quickly and other times it really does tend to, the trend seems to be consistent?
Yeah, I mean, in general, so one of the reasons we have skill with these seasonal forecasts is there does tend to be a lot of, basically some of this persistence in the tropics. So if the water is warm today and you correlate the water in July, water temperatures in July with August and September, they generally correlate very highly. So there's not a lot of change month on month. If it's warmer than normal now, it's generally warmer than normal in August and September, the peak months of the season. There are some years that throw you curveballs, and you mentioned 2013, which is year I was not particularly.
It's notorious that year.
In October,
Yes.
as we forecast, I believe 9 hurricanes, and we got 2.
Yes.
So that was not a banner forecast for our team. But one thing I was looking at is if you look at, say, 2013, even by now, the water temperatures had cooled. If you compare 2013 with 2020, say, it was a lot cooler in 2013 now than it was a lot cooler in 2013 in late July than it is in 2020 in late July. We've also
that change happened in July, right? It was in July that it made the turn to getting cool. Yeah.
So one of the things I ignored in 2013 to my peril was basically when you get cold water off of the west coast of the Iberian Peninsula, so off of Portugal, if you get cold water there in June and July, that tends to force higher pressure and stronger trade winds into the deep tropics for the peak of the season, causes more churning, mixing up of the ocean surface. We had that in 2013, and I ignored it to my peril. This year, we do not have it. Now it's actually one of the specific predictors in our model. So the models are coming out a lot higher. One of the things I also did not have in 2013 that we have now with our seasonal forecast is that we also include basically what's known as a statistical dynamical model. So basically we have a numerical model, so the European Center climate model forecasts large-scale conditions, and we look at what the climate model is forecasting and see does that match up with what our statistical model says, and we have kind of additional tools that we have in our toolbox that we didn't have 7 years ago. These climate models, back in the mid-'80s when Bill Gray was starting these forecasts, were lousy, were in their infancy, were super low resolution, whereas now, with improved computational power, you actually can get some skill, not necessarily forecasting, the weather 7 weeks from now, but forecasting, say, next month the pressures are going to be low, or the temperatures are going to be warm, things like that.
And obviously, the other thing that's a big part of your forecast, besides the temperature of the Atlantic water, is the temperature of the water in the tropical Pacific, the equatorial Pacific, whether it's an El Nino or a La Nina, the so-called ENSO state there. So what do we think about this slightly cool state, which is where we are, right? It's not it's technically a neutral state. It's technically not La Nina, but it's sort of edging that way. Does that give us an indication of anything, or does that just mean it's more of a toss-up of what the influence of that will be?
Yeah, so right now, while we officially, you said, are in the neutral state, if you look at the overall tropical circulation, it is almost exactly, if you're looking for an active season, almost exactly matches up with what you're looking for an active season. We've had a lot of suppressed motion over the tropical Pacific Ocean, and we've had a very, very quiet typhoon season so far. We haven't had a typhoon since the middle of May. It's been extremely quiet in the western North Pacific. We've had a lot of air rising up over Africa and Indian Ocean, and that typically associates with upper-level easterly winds in the Atlantic, and that counteracts your normal westerly winds, which means a lot less vertical wind shear. So from that perspective, we think overall, the large-scale conditions over Africa and India certainly kind of match up with what we expect for an active season. So while we certainly don't have officially La Nina conditions yet, and we might not actually meet that threshold. The atmospheric circulation, which is what I'm looking at in terms of how it's going to impact the Atlantic hurricane season, is looking more La Nina-like in that we're seeing suppressed motion over the Pacific, rising motion over Africa and India, which results in lower shear in the Atlantic, which is really, we look at the water temperatures, that's important, but really the Atlantic is the shear is really the key. Mm-hmm. It's a very marginal basin. So, you can have a year where the shear is low and you can get 15 hurricanes like we did in 2005. If the shear is high, you can get very few, 2 or 3 hurricanes when the shear is high if you have a strong El Nino or other factors come into play. So really for us, if I had to pick one factor to look at it, it's the shear. And the shear so far has been also quite low. It's not top 5. I think last looked it was like the 6th or 7th lowest shear in kind of the deep tropics. So when you have low shear, warm water, and enough mid-level moisture, it's usually shapes up to be a very active season.
Yeah,
which is why.
And that includes the Caribbean as well with the very low shear. This whole question of whether we have an El Nino or La Nina, I mean, generally that's dependent on this box that has been drawn in the Pacific, and they measure the water temperature in the box and compare that to normal. But there are other people that have made indices to really try and talk about the atmosphere and what the atmosphere is doing, as opposed to just pegging it on that one box, more sophisticated ways of trying to identify that. And as you say, atmospherically, it looks like what we would think of as being a La Nina kind of year.
Correct, yeah. And again, what I'm looking at is going to be different than because basically, I don't honestly really care what the water temperatures are like in the tropical Pacific. It's more how it impacts the Atlantic circulation. That's what I'm most care, or basically the global tropical circulation. And so, for example, 2004, we officially had El Nino conditions even in like August and September, but as those of you in Florida remember, 2004 was not a quiet hurricane season, and it was around October 1st that we suddenly started getting this big intrusion of upper level westerlies, and the season basically shut off October 1st, but of course by then Florida had been very significantly impacted by 4 hurricanes, so it didn't do people in Florida any good. So even though it may have officially met the El Nino threshold, it's how the atmosphere responds, and sometimes the atmosphere, in addition to responding to what the water temperatures are in that box you mentioned in the tropical Pacific, also responded ocean temperatures in other parts of the world as well. So it's important to kind of, for my purposes, I obviously look at those specific ENSO indices that they use, but also look at other factors too, in terms of how it may impact overall the tropical Atlantic. So as you mentioned, they measure water temperatures in a box in the tropical Pacific, and the threshold is very low. It's 0.5 degree Celsius, which seems 0.9 Fahrenheit.
Right.
What is that? That's, if it was 87 or 88 in your swimming pool, you probably wouldn't notice the difference. But it makes a big difference in how the atmosphere then responds. And a strong El Nino, you're talking, 3-4 degrees Fahrenheit, which still doesn't seem that much, but that makes a huge difference in how the atmosphere then responds. So small changes in the tropics make big changes in the atmospheric circulation. It's very different than the mid-latitudes where you get a 30-40 degree temperature swing pretty often.
Yes, a couple times a week sometimes.
Exactly. In Colorado, you can set your record high and record low on the same day.
Yeah, exactly. It's crazy. All right, so taking all of that into account, so what's your thinking for this hurricane season? I know you're putting the finishing touches on your forecast update coming out in a week or so, but obviously things are looking busy. Where do you stand?
Yeah, so we're forecasting a very, very active season. Our last forecast was for 20 named storms and 9 hurricanes, 4 major hurricanes. We're putting out our forecast next week. Certainly the forecast, I will say, will probably not be going down any, given what we've not necessarily what we've seen to date, although assuming this potential tropical cyclone 9 does form, getting 2 storms forming in the deep tropics, so Hannah form more in the Gulf, but if we look at storms forming usually from, say, the Eastern Caribbean further east and in the deep tropics, those are usually a sign harbinger of a very active season. It's more of a sufficient condition than a necessary one. If you get that typically means a very active season, but there's been plenty of seasons where we haven't seen storm formations in June and July in that region, but still end up very active. A great case in point of that would be 2004. We didn't get our first named storm in 2004 until August 1st, and we got
and then it went crazy. Yes.
Just August, September. Then
right.
October came and it was very quiet. Right. So, you can have seasons that are kind of more spread out, like 2005, or you can get these seasons that are really tightly packed. Bill Gray, my mentor and founder of the seasonal forecast, used to ring a bell on August 20th and say, this is the real active part of the hurricane season. You get something like 85% of your major hurricanes just between August 20th and October 10th, October 15th. So there's a really tight window in the Atlantic when the season really, really ramps up. Although obviously, as you know, living in South Florida, while say the risk of getting hurricane activity in Texas in October is very low, as you know, in South Florida, October you could still has a pretty high risk of getting storms in South Florida. So the season in Florida, unfortunately, lasts a bit longer than it does for other states. Yeah,
September and October are about equal in terms of historical hurricanes, although the strongest ones normally come in September. Although, in South Florida, most people don't think about this, but there has never been in the database, going back to 1851, a hurricane in the first half of August. And as a matter of fact, there's only one hurricane in 1888 that hit before August 24th, the Andrew date. So it really is, as Bill Gray used to say, because he spent a lot of time in Miami as well, August 20th through October 20th really is that 2-month period is the heart of hurricane season in general.
Yeah. Well, that's typically, like you said, the main development regions, so the deep tropics, where a lot of the storms that hit Florida come from, doesn't really get conducive until about August 5th and 10th. And so by the time the storm would form and then track all the way across the basin and hit Florida, you're getting to about August 20th. So yeah, the hurricane season starts June 1st, and this year is kind of a red herring that you had a whole pile of storms already, but normally the season really doesn't ramp up for a while. You've got to wait a few more weeks till the season really ramps up. So, we have this potential tropical cyclone 9, Isaias, and then it looks like maybe things will get quiet for a little bit, maybe 5-10 days of nothing in the Atlantic, but certainly not to say, okay, the season's a bust or it's getting quieter. There's certainly plenty of time. The season really will ramp up probably mid to late August. Right on schedule when Bill Gray usually rings the bell.
Yes, exactly. Do you think the day is coming that computers will do the seasonal forecasts that you guys have worked so hard on, that you and Bill and Michael Bell, Dr. Michael Bell, your partner now, weigh all these various things? Do you see that coming by, artificial intelligence or some kind of computer program at some point?
So I think there's a variety of different kind of approaches that are done. There's kind of the statistical approach, which is the classic Bill Gray, look at the past, develop statistical models based on past years and run them. And I think there's always going to be a need. It's always good to run these kinds of models. There's also dynamical models, which basically is saying, okay, we're going to run a full physics climate model forward and say, count the number of vortices that the model spins up. And that's kind of, I guess, what you consider like the wave of the future. But those models still have a hard time spinning up strong enough storms, and they don't always work super well. And so what I found is that, or for not just me, others have found as well, if you do these kind of a statistical dynamical hybrid approach where instead of forecasting, counting the number of vortices, you just look at the large scale conditions, you can get just as good predictability from forecasting the large scale conditions as counting the model vortices, if not even a little bit better. So I think kind of these hybrid approaches of a statistical dynamical model, I think personally is probably what we're going to use a lot of. Obviously, one of the benefits of the dynamical models is tantalizing is can they forecast where the storms are going to track? Because again, that's always what we would say is like,
right.
Okay, we can give you a prediction for the basin, but we don't have a clue where they're going to go. We could say in general, more active seasons have more landfalls, but obviously, as you know way better than I do, Bill Gray had a great forecast in 1992 of a major hurricane. And there was only one. It was the first,
exactly.
the first storm that NHC named at the time. But it was a little just had a few, impacts in South Florida there with Andrew obviously being absolutely devastating in 1992. And so, but in general, more active seasons do have more landfalls. But if you can start to get ideas of where the storms are going to track, not a storm's going to form August 20th and hit, Miami on September 2nd, but to say, okay, in general, the storms look like they're more going to track along the East Coast or into the Gulf. And also, I think one of the things that maybe we can do even from a statistical approach is try to forecast where the storms are going to form. Because obviously, if a storm forms in the Gulf of Mexico, it's got to hit somewhere.
It's not hitting North Carolina if it forms in the Gulf of Mexico.
Exactly.
Right.
Whereas if a storm forms right off the East Coast or right off the West Coast of Africa, they can track all the way across and go into the Gulf or hit the East Coast. But in general, if they form right off of Africa, they tend to recurve because it just tends to be basically stronger storms move slightly north of due west, so if something comes in the mid-latitudes, picks it up and takes it out. But there's obviously exceptions, like Irma formed right off of Africa.
Right.
If you look at like the climatology models, they were saying, it should just recurve, but unfortunately there's a really strong ridge that drove it straight west. But if you can do those kinds of forecasts, I think that's kind of stuff that we're looking at as well, is statistical dynamical models of kind of the large-scale environment, trying to figure out where the storms are going to form, and then maybe looking and seeing how well do those models forecast the mid-latitude steering flow. I don't think you're going to do very well in a season. It's really hard to look at a 3-month average of height fields in the mid-latitudes and say, okay, that's what's going to steer the storm, because storms are governed by day-to-day weather patterns, how they're going to track. And while there's a lot of persistence in the tropics, there's very low persistence in the middle latitudes, which is what usually kind of ends up steering the storms, whether they end up hitting the U.S. or recurving. And you have you have cases, like a Matthew or a Dorian, where it was so close to Florida, and there's no way you could do that on a seasonal time scale to say, Matthew's going to recurve, 60 miles off the coast, or Dorian's going to, wall up the Bahamas as a Category 5 and have relatively minor impacts in the U.S. Normally, if you get nasty hurricanes hitting the northwestern Bahamas, those are usually the really, really bad ones. The 1928 Okeechobee hurricane comes to mind as well. It was really, really bad in Florida as well. And Andrew as well, 92.
Yeah, exactly. So a few years ago, we talked about, there was talk about the idea that the era of more hurricanes might be coming to an end. Now, we don't hear that talk so much anymore. We think these eras are 25 to 40 years of more hurricane activity that started in 1995. Do you have a sense of how we're going to know when it comes to an end? Obviously, with this year going crazy and having had so many storms in the last few years, like I said, nobody's saying that anymore. But is this something that we're only going to know after it's over, and then we look back and say, I guess it ended, a few years ago, because now it seems like not as many storms are happening? Or how are we going to detect that this is happening?
Yeah, and it's tricky. And so you're right. We published a paper where, I'm glad we ended it with a question mark, but we said, okay, we had 2013, 14, and 15, 3 very quiet hurricane seasons. And honestly, 2016 through the end of September was very quiet. And then we had Matthew and Nicole late that really amped up the numbers and got us to above average. So even with 2016, we were thinking, maybe this kind of active era is coming to an end. And then obviously we saw 2017, which was certainly anything but quiet. 2018 was a really odd year. Normally, normally if a seasonal forecast doesn't go great, usually it's because things don't pan out the way we thought. Either the waters are warmer or colder than normal, we get an El Nino. Whereas 2018, even if you knew perfectly, if you showed me a map of September and said, okay, how many storms, or showed me a map, say, of August to October average conditions, I would have still said that should have been a below average season. And so we wrote a paper that actually got published a couple of months ago looking at 2018 and showing how historically, if you'd used the shear values, the SS, it was basically what you would call like effectively an overachieving hurricane season, where basically it generated more ACE or more hurricane numbers than you would have expected given the large scale. And you get those sometimes, or vice versa.
Well, Dorian, of course, was the big part of that.
Well, yeah, so 2018 was Florence and Michael, and Florence especially.
2018, yes, 2018.
2019 was a reasonably good forecast. I think it generated a little higher than what we thought, but we were thinking a little above, and it was just a tick more than what we were expecting. But there was a lot of subtropical kind of
Yeah, but going back to 2018, that had Florence in it. And Florence, I mean, tracked through the subtropics in a whole different zone, really, than you're forecasting, right? So
correct, yeah, and that's one of the
that fouled it up, I'm sure.
Yeah, and also we had Leslie, which generated a whole lot.
Oh, that in the Eastern Atlantic, that was the huge thing in the Eastern Atlantic, yes.
Yeah. So you get those kind of situations too. So there's skill in these seasonal forecasts, but there also is noise. But getting back to your original question, since I nicely segued to something else, So normally what kind of the historical relationship is that basically it's related with this Atlantic multi-decadal oscillation, whereby you have warmer water for about 25 to 35 years, especially in the far North Atlantic, and then it's colder. And so the last few years, if you look at the far North Atlantic, it's been fairly cold, a lot of cold water up in the far North Atlantic, much colder than normal. And normally when you have that, it correlates to higher pressure in the subtropics, which force cooler water into the deep tropics. And that relationship has worked a bit in the winter, but it's fallen apart in the summer. And obviously, we don't really care what's going on in the winter because that's not our hurricane season. By the time the summer rolls around, the waters have warmed up quite a bit, warmed up faster than normal. And so this year, the tropics have always been a little bit warmer than normal, but we've certainly seen a lot of warming, even just over the last few weeks, warming up a lot faster than normal. So we have a lot more fuel for the storm. So yeah, I mean, it's tricky. We tried in 2013 to 15 to make that, and I think the overall, so this Atlantic thermohaline circulation, which is salt and temperature-driven circulation of the ocean, that seems to be weakening. There's lower salinity, there's cold water in the far North Atlantic, but it's not having the same impact in the tropical Atlantic. And maybe it's just a few years where it's kind of not behaving normally, or maybe there's other climate change factors coming in. It's hard to really know exactly what all that is exactly tied to. But I will also point out that Bill Gray in 1990 was asked the same question, are we coming out of the quiet period? Because we had 70 to 87, which were all generally very, very quiet. And then we had 88, 89, and even 90 were both three reasonably active seasons. And then we had 4 years where we're very, very quiet. Obviously, we had Andrew, but basically that was pretty much only show in town for 4 years. And then 95 is when it really ramped up. So sometimes the atmosphere and ocean keep you humble. There's a lot of questions and a lot of things going on. And also, too, you have natural variability in the climate system. You have climate change, and we don't necessarily understand how all these things interact. But yeah, I mean, unfortunately, I would love it if I could replace the question mark with an exclamation point, but unfortunately, that doesn't seem to be the case given what we've seen the last few years. And you're right, there has been a lot less questions about the end of the active era recently.
Yeah, in the late 80s and early 90s, I remember Bill Gray talking about Florida being a sitting duck because he believed that hurricanes were going to ramp up and inevitably hurricane would come to Florida. Now, the big one at that time, 1992, came in the slow era, right? We hadn't really ramped up overall hurricanes by that time. But Bill was very prophetic in terms of the way that the atmosphere was going to work. And I think a big question is whether this oscillation that goes back and forth every 25, 35, 40 years, whatever it is going to continue the way it does it now that we're putting all this fresh water in the northern Atlantic, how that might affect the salinity, how that might change the oscillation of that circulation. We know the Gulf Stream is slowing down. We can see it in sea level rise. It's contributing to sea level rise, at least slightly. So anyway, I think to me that's a big open question.
Yeah, so I mean, if you look at that, so basically what you just said, that helps lead to a weaker thermohaline circulation, which should theoretically lead to fewer Atlantic hurricanes because you cool the tropical Atlantic, and we haven't really seen that. Right. So basically, Bill Gray has this kind of chain of events where you have a weaker thermohaline circulation, you get colder water in the far North Atlantic, and then through all these what's known as teleconnections, so how changes in water temperature in one place impact pressures that then impact winds. That should theoretically lead to cooler tropical Atlantic, but it really hasn't. And so,
right.
But if you look historically, there's been times in the past where the far North Atlantic and tropical Atlantic haven't correlated very well, and it might just be one of those periods, or maybe it's something climate change related, and it's just not going to work as well in the future. And unfortunately, I guess we can redo this podcast again in 20 years and revisit that question and see what happened.
Yeah, I think it's another one of those things that we're going to have to look back on to understand what happened as opposed to understanding what is happening while it's happening. Just one more thing I wanted to give you an opportunity to talk about. People, I think, oh, we're having so many more hurricanes now than we used to. And to some degree we are, if you look at a short history of somebody's adult lifetime, for example, for the reasons that we talked about. Before 1995, there were fewer on average storms coming through for the previous couple decades before that. But it isn't at all the case that back earlier in the century, we had all quiet seasons by any means, not to mention the great hurricanes of the 1920s into the 30s. But people here, and naturally focus on 2005 as being this super hyperactive season. But you've recently been looking into, and have you published the paper, or it's not published yet, or you're going to publish it on 1933? And tell us about why the 1933 season was worthy of really looking into in detail.
Yeah, so the paper's been submitted. It's currently under review in the Bulletin of the American Meteorological Society. Given the hurricane season and given who it probably went to as reviewers, it might be a while before we get their reviews back. We'll see. But 1933 was a phenomenally active Atlantic hurricane season. So if you look at the accumulated cyclone energy, so again, an integrated metric we talked about earlier, it had even more than 2005. Mm-hmm. And that was before we had satellite imagery, before we were flying airplanes into storms. So if you look at the tracks of the storms in 33, they don't really go very far east in the Atlantic, and that's just because we couldn't observe them. So the ACE number that we have is probably even a little low. But it was a phenomenally active hurricane season. And so we wanted to do a little more, kind of give it a little more justice and really go in and try to figure out what made 33 as active as it was that predictable? 33 also, we had this recent discussion with Hannah making landfall in Texas, and then Douglas, which didn't officially make landfall, but there was a lot of question. Would this be the first time we'd ever seen two hurricanes hitting the U.S., within a day of each other? And in 1933, we had two high-end Category 3 hurricanes, each with 125-mile-an-hour winds, make landfall 23 hours apart. The Treasure Coast hurricane in Florida, followed by the Cuba-Brownsville hurricane near Brownsville, 23 hours later. And so there's one of the figures we have in our paper just shows a surface weather map, just showing a hurricane right on land, another hurricane bearing down. And so, that's what's happened in the history books, let alone what might happen in the future. And obviously for Florida, South Florida, as I know, Brian, we had 5 Category 4 hurricanes hit South Florida in just 6 years between 1945 and 1950. And again, that's just historical hurricanes. That's not even touching climate change. So there certainly are these periods where Florida gets hit by more hurricanes. Somewhat it's this multi-decadal signal. There's also just basically good or quote-unquote good or bad luck involved with just what the steering happens to be on the day. Obviously, Florida, between Matthew and Dorian, has dodged 2 huge bullets. I know Matthew brought some impacts and Dorian less impacts, right. Still some impacts, but certainly had both of those storms tracked 100 miles farther to the west, we'd be talking about two very different situations for the state of Florida than what we were. My mom and sister both live in Brevard County, right on the East Coast, and they certainly, with both of those storms, were watching it very, very, very closely. Yeah,
that's where I grew up. I grew up 2.5 blocks from the ocean and in the Atlantic, across the bridge from Melbourne, and we never had any strong hurricanes when I was growing up there. I mean, we had Cleo and we had Betsy, sort of, but they were kind of leftovers or edge effects and not a big deal. So just one more thing related to 1933. So if you look at those super big seasons, 1933 and going farther back, 1886, 1893, I don't know, here in Miami, I think you'd include 1926 since there were 4 storms right around here, 3 really strong hurricanes very close to Miami, including the Great Miami Hurricane, of course, the greatest of all the hurricanes in terms of potential damage if they happened again. Are you able, looking this far away, this far in the future after those things happen, able to understand what it was about those years? Are they the factors that you look at? Are you looking at the same things that caused those years to be so busy as best you can tell?
Yeah, I mean, so it's tricky because obviously with sea surface temperatures, you have to kind of look at it relative to other years in that general era because we do have kind of that long-term climate change warming. But as you warm temperatures around the globe by a relatively equal amount in the tropics, what you may have needed to get a hurricane 100 years ago, you might need a little bit warmer water now to get that same thing because you're warming. When you warm in climate change, you warm throughout the atmospheric column. It's not just at the ocean surface. But yeah, I mean, we looked at 33, and I mean, as best you can tell, the shear was very low, the waters were very warm, the pressure was low. And so what we have is we have what's called this, there's NOAA put out what's called this 20th century reanalysis, which actually it's called 20th century, but goes back to the 19th century. And so you can look at, it's all based off of just pressure data, which is, if you're going to use one field, pressure is a really good field to use because barometers haven't changed very much. Of course, it's challenging because you only have barometers where you had either land or you had ships. So there's obviously greater uncertainty, but there's kind of an ensemble, so you can estimate the uncertainty associated with those. But if you look back in time, you do correlations of, basically what we use now and correlate it in the late 19th century, they still work. So yeah, basically it looks like it's the same things that made hurricanes now are the same things that made hurricanes 100, 200 years ago. And as you said, like 1926 is basically the year that Bill Gray, and others too, basically said it's the start of not the current active era, but the one before that was 1926 to generally 26 to 69. There were some quiet years in there, but certainly 26 was a gangbusters year, 32, 33, and then the 50s were also incredibly active.
Yeah, late 40s. Yeah. So
World War II was not super active, but then once you started getting into the late, even 44.
44 was busy. You had 2 big storms in 44.
Very active. Yeah. So there's more uncertainty in the data as we go back in time, but in general, especially for hurricanes, it's going to be, if anything, it's going to be underestimated because we didn't, unless a ship happened to encounter it or it hit something, we didn't necessarily know it was there. So Hurricane Center has done their best and reanalyze all those historical seasons, but there's always going to be some uncertainty going back in time just because we don't have the observational capability that we do now.
Yeah, and if you go back and look at those old maps, what you see is all of the tracks over on the Western Atlantic, and there's this huge void on the Eastern Atlantic, so you just know, it's 100% sure that there were other storms that didn't get counted. So when you have storm seasons that we know were busy back then, we actually know they were busier than
correct. Yeah, and if you look at, we like to look also at just landfalling hurricanes, because those we can do pretty well, at least back to 1900, if not the late 19th century. Obviously, certain parts of the U.S. just weren't very densely populated in the late 19th century, like the Florida Panhandle, and there's parts of the Gulf Coast that weren't as densely populated, but certainly since 1900, if a hurricane made landfall anywhere along the U.S. coast, we knew it was there. We may have underestimated it a bit, but if you look at the landfalling hurricanes since 1900 or even the mid-19th century, there's no long-term trend. And even with climate change, we don't necessarily expect to see a long-term increasing trend in, say, the number of hurricanes. The big question is, or kind of the climate change thing isn't necessarily we're going to see more storms, but just they're going to be stronger, effectively. That for every hurricane that forms, the chances of it reaching Category 4 and 5 is likely to get a little bit higher in the future with the ocean surface warming.
Right, exactly. All right, Dr. Phil Klotzbach, thanks so much for being with us on the podcast, and we'll anxiously await your updated forecast, but I'm betting the total number is going to be in the 20s. That's what I'm predicting. It's my prediction.
Sounds good, Brian.
All right, Phil, take care, and we'll see you soon. Thanks.
Sounds good, thanks.
You can bet Phil is busy putting together a new forecast because there is always more information And unfortunately, the information that's coming in makes the season look busier and busier. We haven't talked about Hurricane Douglas yet, and we should do that before we go. Douglas, of course, just passed just north of the islands. I mean, the forecast was actually quite good because just a few miles difference makes a lot of difference there. And boy, that was a very, very close call because hurricanes and all those mountainous islands are really a bad combination. You've probably heard a lot about when Douglas was happening, how that this is like unprecedented, having the strongest storm come from the east. We used to always say that bad hurricanes in Hawaii have to come from the south, like Iniki did in 1992 and some of the other kind of bad storms that have happened over the years, even though not many have hit the Hawaiian Islands since there have been records. Well, it turns out that there was a super interesting storm that apparently also came from the east on a track near the Big Island, just north of the Big Island, sort of like Douglas, although it ended up being closer to the Big Island. It went between the Big Island and Maui. Maui is just to the west. And then it curved north over Molokai, which is just to the west of Maui. So it kind of curved around Maui in 1871. And the reason this is such an interesting storm is because nobody knew about it until somebody decided to translate the Hawaiian language newspapers of the time. And as a result of that, they learned about this very interesting and very damaging hurricane that hit the Big Island and Maui and Molokai back in 1871, August of 1871. That was one of the great Hawaiian hurricanes, but it doesn't get talked about very much. Earlier in the podcast, I mentioned that there was only one hurricane to hit South Florida in August before Hurricane Andrew's date. That was in 1888. It turns out that on the 24th of August and the few days after are kind of popular days for South Florida hurricanes. So as Phil was saying, once we get to the 20th of August, that's when it just becomes much more likely, and the records in South Florida do indeed confirm that, although most of the big hurricanes, the most damaging hurricanes, have come here in September. And in terms of numbers, a lot of them still come in October. So next week, we're going to talk with Dr. Adam Sobel from Columbia University. Adam does a really great podcast of his own where he talks to scientists about being scientists and becoming scientists. And of course, he talks about science. Plus, he's a climate scientist himself. Dr. Adam Sobel will talk about everything to do with science and scientists and climate and meteorology. That's coming up next on the podcast. That'll be next week. So that's it for this week. For Luke Doris, I'm Bryan Norcross. We'll be tracking the system in the tropics, whether it's Tropical Storm Isaias. We'll see. It is forecast to be. We'll tell you all about it on Local 10 in South Florida. Of course, local10.com. Anywhere, we'll have full coverage. Until then, stay well, be safe, and wear a mask.